So, in this session, we will discuss the graphs which explain the motion of an object. As we already discussed about the speed, velocity, and acceleration. So, we can use different types of graph. We can use distance time graph, or we can use speed time or velocity time graphs to explain the motion of an object. So, example, the first one, to explain the motion of an object, we can use different types of graphs. We can use distance time graph or we can use speed time graphs. So first one, we will discuss a distance time graph. And in a distance time graph, there are different ways we explain the motion. For example, if an object is at rest or stationary. So if object is at rest or object is stationary or object is not moving, so what will be the shape of the graph? For a distance and time graph, it will be a horizontal line. How it will be a horizontal line? Example, say this is an object and you're standing at position A. Okay, and this object is at rest. This object is not moving. And the distance between you and the object, example, it is 10 meters. And the object is not moving. On x-axis we have time. So example 1, 2, 3, 4 and 5, and on y-axis we have distance, example 5, 10, 15 and then 20. So in the beginning, at the start of the experiment, this object is at rest, this object is not moving. So in the beginning, when time is equals to 0, this object is at 10 meter from the starting point. So this is the point which we mark to locate the positions, and that object is at 10-meter mark. After 1 second, what will be the position of the object? Because this object is not moving, this object is at rest. So after 1 second, this object will be at 10-meter mark. Then after 2 seconds, this object will remain at 10-meter mark. After 3 seconds, it will remain at 10-meter mark. After 4 seconds, because this object is stationary or this object is at rest, so whenever object is at rest, we mark the points. So what it will come out? It will always come out a horizontal line. So if a question is, in exam they can ask this question in two ways. Sometimes they say sketch a graph for an object at rest, so you will draw a horizontal line. And sometimes they give you the graph and they ask explain the motion of an object. So whenever a distance time graph you have a horizontal line, it means the object is stationary or object is at rest. Is it clear? The first graph which explain that the object is not moving or object is at rest or object is stationary. So in this session we will discuss different types of graphs. First one we will discuss distance time graph, and the second one we'll discuss speed time or velocity time graph. Is it clear to everyone? Yes, Abdullah Khan, Heather, Muhammad Hatem, Saim, any doubts? The second type of graph, the distance time graph, which explains the motion when object is moving with a constant speed. When object is moving with a constant speed, what will be the shape of a distance time graph? So it will be a straight line which is passing through origin. An explanation of this: the term constant speed means that object travels same distance in equal time interval. So this is the position at 0 seconds, then 1 second, 2 seconds, 3 seconds, and 4 seconds. Position A, B, C, D, and E. The distance between A and B example is 2 meters. Distance between B and C is 2 meters. C and D also 2 meters. And D and E is also 2 meters. Now, what is the speed from A to B? When we calculate the speed of this object from A to B, speed means distance travel in a unit time. So speed from A to B, the distance travel, that is 2. And how much time it took? It started at 0 seconds, and at position B, it reaches after 1 second. So 2 divided by 1. So between A and B, the speed is equal to 2 meter per second. What about speed from B to C? So when we calculate the speed of this object from position B to C, the distance traveled from B to C, that's equal to 2, and the time at position B it was at 1 second, and at position C it is at 2 seconds. So the time interval, it will be 2 divided by 1, and again it will be 2 meter per second. Same thing from C to D, it traveled 2 meters and it took 1 second, so speed is 2 meter per second. And from D to E, the distance is 2 and the time interval is 1, so it will come out as 2 meter per second. So whenever speed of an object is not changing, we use the term that this object is moving with uniform speed, or we can also say it is moving with constant speed. And how the distance time graph will appear, what will be the shape of a distance time graph, how we work out? It will be a straight line, but how it will be a straight line? With a constant slope or gradient. So when we mark the positions, the points, on time axis we have 0, then 1, 2, 3, and 4. And on x-axis we have distance. Example, this one is 2, 4, 6. So distance 2, 4, 6, 8, and 10. So we want to plot a distance time graph for this object which is moving with a constant speed. So in the beginning, when time is equals to 0 second, or at the start, the object just about to move, so it is at this point the distance is 0. That's the first point. Then after 1 second, what is the total distance traveled by the object after 1 second? The distance traveled by this object. So that's equal to 2 meter. So after 1 second, the object is at 2 meter mark. Then after 2 seconds, After 2 seconds, what is the total distance traveled by the object? So that's equal to 4. So after 2 seconds, the object is at 4 meter mark. Then after 3 seconds, it is at 6 meter mark. And then after 4 seconds, it is at 8 meter mark from the starting point. So when you join these points, how it appear? It will appear that these points are coming in a straight line. So when we join these points and draw a line through these points, so we'll have a graph in this manner which shows this object is moving with a constant speed. So whenever object is moving with a constant speed, what you will get? You will get a straight line of constant gradient or constant slope. Is it clear? The distance time graph for an object which is moving with a constant speed. Is it clear to everyone? The shape of the graph, distance time graph for a constant speed. If two objects are moving with a constant speed, using a graph, you can also work out which one is moving at a higher constant speed. Abdullah Sarfraz, the graph is a distance time graph. Okay. So what we did, this is a distance time graph. So we mark the axis. On x-axis we have time. On y-axis we have distance. So in the beginning, when time is equals to 0, the object is at the starting point. Now after 1 second, how much distance covered by the object? Abdullah Sarfraz. After 1 second, what is the distance covered by the object? Abdullah, you can use a mic to answer quickly.
4.
Yes, Abdullah Sarfraz. What is the distance traveled by this object after 1 second?
After 1 second, it's 4, but before it's 2.
After 1 second, here. It is at, this is
Before
a
it's
starting
2.
point. This is a starting point. And after 1 second, it is at position B. So what is the distance traveled by the object after 1 second?
2 meter.
2 meter. So so when the time is 1 second, the object is at 2 meter mark. Is it clear, the first point?
Yes.
Now after 2 seconds, 2 seconds from the beginning, so when it is at 2 second, after 2 second, what is the total distance traveled by the object from the starting point?
4.
That's 4. So after 2 seconds, the object is at 4 meter mark. So when time is 2, the object is at 4 meter mark. We will mark that point. Then after 3 seconds, what is the total distance traveled by this object from the starting point?
6.
6. So we will mark after 3 seconds, the object covered total 6 meters. And after 4 seconds, what is the total distance covered by the object? Total
8.
distance 8. So this is, we'll mark that point 8. And when we join these, because in a graph we join the points to draw a line, so when we join these points, it will come out as a straight line. So whenever object is moving with a constant speed, the distance time graph is always a straight line. Is it clear now?
Yes.
If two objects are moving with a constant speed, example distance in time, so two objects are there, both are moving with a constant speed. Because it's a straight line, so we know both are moving with a constant speed. And these are the values like 10, 20, 15 is there in between, 5, and the time axis 2, 4, 6, 8, 10, and 12. My question is, which object is moving at a higher constant speed? Which object, A or B, is moving at a higher constant speed? So which object, A or B, is moving at a higher constant speed? I want participation from everyone. Don't bother about the wrong answer, but your participation is important. Which one you think is moving at a higher constant speed? So the right answer is A. Why A is the right answer? First thing, A is a steeper slope. Second thing, you can also find the value. How you can find the value of the speed? Speed is distance divided by time. So how to get the speed of the object here? For A, what is the distance traveled by A? A covered 20 meters. And what is the time interval to cover this 20 meters? So A covered 20 meters, and how much time it took? It took 4 seconds. So it will be, for A, when we are finding the speed, it will be 20 divided by 4, because distance traveled by time, that's equal to speed. So 20 divided by 4, that's equal to 5 meter per second. But what about B? For B, it covered 15 meters in 12 seconds. So for B, when you find, it will be 15 divided by 12. So that is equals to 5 by 4, or 1.25 meter per second. Is it clear how we work out the objects with a steeper slope are moving faster, as the graph, distance time graph, which shows a steeper slope or a greater slope or angle, shows that the object is moving at a higher speed. Is it clear? So the first case we discussed, for a distance time graph, we discussed when object, Abdullah, how we can find the speed? Speed is distance travel divided by time. So what is the distance travel by A? When we check the distance travel by A is equals to 20, and the time is equals to 4. So 20 divided by 4, that's equal to 5 meter per second. So A covered 5 meters in 1 second. But what about B? The distance traveled by the B is 15, and it took 12 seconds to complete that distance. So when we find the speed, distance divided by time, so 15 divided by 12, that's equal to 1.25. So it shows that B is traveling slower and A is traveling faster. Or without calculation, you can also work out the graph lines which are having a steeper slope or a greater angle shows the objects are moving at a higher constant speed as compared to the lines which are less steeper. So example, we have two lines here representing a constant speed. So which object is moving faster, A or B? Without calculation, no numbers are there. So which object is moving faster? How you can work out? You can check the slope, the angle. So A is having a steeper slope or a greater angle. So A, the object is moving faster at a higher constant speed, and B is having a lower constant speed. Why it is a constant speed? Because it's a straight line. Whenever it's a straight line, it means the speed is constant for a distance time graph. And which one is higher and which one is lower? So you can simply check the angle. The one which is making a greater angle with x-axis, you can see A, the line of A is making a greater angle as compared to B. So it means it will have a higher value, or steeper slope shows higher speed. So the first graph to explain the motion of an object, we discussed that if an object is at rest, it will be a horizontal line for a distance time graph which shows that object is not moving. The second part we discussed, if an object is moving with a constant speed, it will be a straight line for a distance time graph at a constant gradient which shows object is moving at a constant speed. Then object speed might increase or speed might decrease, which we also call deceleration. Then what will be the shape of the graph for a distance time graph? If a speed is increasing or accelerating, it will be in this manner, the angle will increase, and if it is decelerating, the angle will decrease. I will explain both of them with numbers. So example, the first one, if object is accelerating, or we can say speed is increasing. So this is an object, position A, B, C, and D. This is at the beginning 0 seconds. At position B it is 1 second, and position C it is 2 seconds, and position D it is 3 seconds. The distance traveled from A to B is 2 meter. From B to C example it is 5 meters, and C to D it is 12 meters. Now what about speed of this object from A to B? So to get the speed, the formula, we know speed is distance travel divided by time taken. So from A to B, what is the distance travel from A to B? It covered 2 meters. Divided by how much time it took to travel from A to B, it is 1 second. So 2 meter divided by 1 second, so it will come out as 2 meter per second. So moving from A to B, the object is moving with 2 meter per second. But what about speed from B to C? At position B, from position B to position C, the distance traveled from B to C is 5 meters, and the time it took to travel from position B to position C, the time interval that is equals to again 1 second. So it will be 5 divided by 1, it will come out as 5 meter per second. And when we calculate speed of this object from C to D, the distance traveled from C to D is 12 meter, and again the time interval from C to D is 1 second. So 12 divided by 1, it will come out as 12 meter per second. Whenever the speed of an object is increasing, the value of the speed is increasing, what we call, or what we say this object is accelerating because the speed is increasing. And when we plot or when we sketch a distance time graph for this object, is it clear with numbers? Then I will sketch a distance time graph. Is it clear, the numerical explanation of acceleration? Whenever speed of an object increase, we call that object is accelerating. So when we plot a distance time graph for an object which is accelerating, so on y-axis we have distance, and on x-axis we have time. And we take the time interval, example, this is 0, then 1, 2, and 3. And the distance, example, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Now, after 1 second, what is the total distance traveled by this object? After 1 second, what is the total distance traveled by this object? So after 1 second, this object covered 2 meters. So when time is equals to 1, object is at position at 2 meter mark. So I will mark that position which represent that object covered 2 meters after 1 second. Then after 2 seconds from the beginning, what is the total distance traveled by the object after 2 seconds? The total distance traveled by the object after 2 seconds. So the total distance from the starting point, that is equals to 7 meters. So after 2 seconds, the object covers 7 meters. So 7 will come between 8 and 6 and 8. So 7 will be here. Then after 3 seconds, what is the total distance traveled by the object? The total distance traveled by the object after 3 seconds. So 2 plus 5, 7, and 7 plus 12. That's equal to 19. So this object after 3 seconds, the total distance which it covered, that is equals to 19. So it will be somewhat here. So when I join these points to draw a graph or complete a graph, so when I join this point, how it will appear? It will appear as a curve. So whenever an object is accelerating, it will be a curve, and the slope of this curve will increase. Is it clear? The distance time graph which is explaining the motion of an object. Is it clear now? My audio is lagging, or is it fine? Look, if we want to plot a distance time graph for an object which is accelerating, it means that the speed is increasing. So how we plot a distance time graph for an object which is accelerating? So example, on x-axis we have time, on y-axis we have a distance. So this object, after 1 second, you can see from the starting point, after 1 second it covered 2 meters. So we will mark a point after 1 second it covered total distance of 2 meters. Then after 2 seconds it covered a total distance of 7 meters. So we will mark a point when time is equals to 2, the total distance will be 7. And then after 3 seconds, the total 3 seconds, it covered, what is the total distance covered? 2 meter plus 5 plus 12. So total distance covered by this object, that is equals to 19. So when we mark the point, 19 will be here. So when we join these points, what it will come out? It will come out as a curve for which the slope is increasing or it is getting steeper. So whenever in exam they say sketch a graph to show, sketch a distance time graph to show object is accelerating, then your graph should appear as like this one which I drew. Is it clear now? And the last case, when the object is decelerating, the term decelerating means the speed is decreasing. So when the speed decreases, we call that as a deceleration. At 1 second, the beginning it's 0, then 1 second, 2 seconds, and 3 seconds. From position A to position B, it covered 5 meters, then it covered 3 meters, and then it covered 2 meters. So when we calculate the speed here for this object from A to B, so speed from A to B, the distance traveled from A to B is 5 and the time is 1. So the speed is 5 meter per second from A to B. If we want to calculate speed from B to C, so distance travel is 3 and the time interval from B to C is 1. So that's 3 meter per second. And speed of an object from C to D, the distance travel is 2 and the time interval is 1. So it is 2 meter per second. Whenever speed of an object is decreasing, we use the term deceleration, or we can say this object is decelerating. Because the term deceleration means speed is decreasing. And if we want to sketch a graph, a distance time graph to show that the object is decelerating, so on x-axis we have time, on y-axis we have the distance. Distance is there in meter and time is there in second. So 0, 1, 2, 3. An example 2, 4, 6, 8, 10. So for a distance time graph in the beginning, after 1 second or till 1 second, the distance traveled by the object, the total distance it covered, that is equals to 5 meters. So till 1 second it covered 5 meters. So 5 will come out at this position. Then till 2 seconds, how much distance it covered? So 5 plus 3, that's equal to 8. So till 2 seconds it covered 8 meters. And till 3 seconds it covered total distance of 10. So till 3 seconds it covered total distance of 10. So when we join these points, how it appear? It appeared that the angle is decreasing, or the line, the steepness of a line is decreasing. So whenever object is decelerating or speed decrease, this is how the graph will appear. Is it clear? The deceleration. So basically there are four graphs which you have to keep in mind for a distance time graph. So what are the four graphs which you have to keep in mind? Number one, when object is at rest or stationary. Number two, the object is moving with a constant speed. Number three, the object is accelerating. And number four, the object is decelerating. So when we sketch a graph, a distance time graph for this motion, time is there on x-axis and distance is there on y-axis. Distance time. So if the object is at rest, then it will be a horizontal line. It can be horizontal line above the origin or on the origin. If it is moving with a constant speed, it will be a straight line. If it is accelerating, the slope, the angle of the line will increase. And if it is decelerating, the angle of the line will decrease. So these are the four graphs which you have to keep in mind whenever you are explaining the motion of an object, because in exam sometimes they give you the graph and they ask explain the motion, sometimes they ask you to draw or sketch a graph for any one of these cases. So I'll continue the discussion and share another link.